Hi guys, welcome to an Academy KCET YouTube live session. Myself Sharif. In this particular video, we will discuss the PYQs of matrices and determinants part 2. Part 1, we have done 25 questions. We'll start with question number 26. And before I start, guys, please do subscribe and enable the bell icon so that you get notification for all our classes. And if you've already subscribed, please do share this video at the end of the session. And below the description box there's a detail written. Please go through that description box. Right, let us start, guys. Question number 26. A into A transpose, I'm supposed to find out what is A into A transpose, right? So A into A transpose is equal to A is matrix cos alpha, sin alpha minus sin alpha and cos alpha. Okay, this is matrix A into A transpose. A transpose will be equal to, first row becomes first column and second row becomes second column. This is minus sin alpha cos alpha. Okay, now A into A transpose is equal to, multiply first row first column, it will be cos square alpha plus sin square alpha. First row second column, this is minus sin alpha minus sin alpha cos alpha plus sin alpha into cos alpha. Second row first column, get minus sin alpha cos alpha plus cos alpha sin alpha. Second row second column, you get sin square alpha plus cos square alpha. This will cancel this as well. A into A transpose is equal to 1 0 and 0 1, which is same as I, unit matrix I. Answer is option D. Right, let's move to the next question. Question number 27. Right, we have done a similar question in the previous PYQ as well. If you have supposed determinant of 5a, if you take 5 outside the determinant, it is 5 power n into determinant a. N stands for order of the matrix. Okay, n is order 3, so n is equal to 3. If I substitute, you get 5 cube into determinant a. 5 cube is 125. 125 into determinant a. Okay, that is answer option B. Right, they can ask any question, guys. We are doing just PYQs of KCET. They can ask any question. Be good in the concept. Right, learn the concept and apply in MCQs. These are all previous KCET questions only. It is given in the question that B is the inverse of A. That is, B is equal to A inverse, right? If I shift on the left side, you get AB is equal to I. Right, this 10 I shift on the left side. Matrix A will be equal to 1 minus 1 1. This is 2 1 minus 3. And then this is 1 1 1. B is equal to 1 by 10 into matrix that is equal to 4 2 2. Okay, minus 5 0 alpha. And then 1 minus 2 and 3. Okay, is equal to 1 0 0 0 1 0 0 0 1. Okay, now I'm going to multiply this first row first column. This becomes 4 minus and minus is plus 5 and plus 1. That is first row first column. Then first row second column, you will get this is 2 minus 0 minus 2. First row third column, you will get 2 minus alpha plus 3. If I cross multiply 10, I'll get 10 0 0. 10 0 0 0 10 0 0 0 10. 10 0 0 0 10 0 0 0 10. So by equality of matrices, I need not find everything. If I equate, you get 5 minus alpha is 0. 5 minus alpha equal to 0, right? alpha equal to 5. Answer is option B. Right, question number 29. See, this is the determinant is equal to 0, right? The first row will be equal to 1 plus x. This is 1 and 1. You change R2 to R2 minus R1. 1 minus of 1 minus 1 minus of 1 plus x is minus 1, right? This is y, right? And this is 0. If I R2 minus R1, if I subtract, change R3 to R3 minus R1. So this is minus x, right? Minus x, this is 0. And then this is my plus z. Right, now if I expand this determinant, if I expand the determinant, 1 plus x, delete first row, first column, this will be yz. Minus 1, delete first row, second column, you get minus z. Plus delete first row, last column, you get xy is equal to 0. So this is yz plus xyz plus z plus xy is equal to 0. First row, first column, first row, second column. R2 minus R1 is change R2 to R2 minus R1. Sorry, this is minus x, right? Minus x, y 0. This is minus x 0 and z. So first row, first column, first row, second column is minus xz. This is minus and minus. This is minus 1. Delete first row, second column, you get minus xz. Okay, and then this will be equal to xyz plus xz plus xy is equal to 0. Right, so this is equal to xyz plus yz plus xz plus xy is equal to 0. If I take suppose xyz common, this becomes 1 plus 1 by yz by xyz. This is yz by xyz plus xz by xyz plus xy by xyz. Okay, and that's equal to 0. That xyz, or you divide by xyz, man. Why am I doing all this? So just divide by xyz. You divide throughout by xyz. If you divide by xyz throughout, you get 1 plus 1 by x plus 1 by y plus 1 by z is equal to 0. So this is x to the power of minus 1 plus y to the power of minus 1 plus z to the power of minus 1 is equal to minus 1. Right, answer will be option A. Understand, guys? Let's move to the next question. Question number 30. Okay, just a sec. You're supposed to find out what is determinant of an. Sorry, a to the power of n. Yeah, you're welcome, Sakshi. Please share those videos, Sakshi. Okay, 2014 to 2022 questions we have done on the platform. Please do share the videos with your friends. A square can be written as a into a, right? That is equal to 1001. This is 1001. So multiply, you get first row, first column, you get 1 plus 0. First row, second column, you get 2 plus 2. Second row, first column, you get 0 plus 0. And second row, last column, you get 0 plus 1. So we go to 1, 2 plus 2, 4, right? 4 can be written as 2 square. Okay, let me keep 4 only. We'll see whether it is I get 4 or 6 there. Next, so this is 1401. This is a square. A cube is equal to a square into a, right? A square is equal to 1 4 0 1, and A is equal to matrix 1 2 0 1. First row, first column, you will get this is 1 plus 0. First row, second column, you get 2 plus 4. Second row, first column is 0 plus 0. Second row, last column, you get 0 plus 1. You will get this is 1 6 0 1. This is same as 1 2 into 2 0 1, right? This is 1 2 into 3 0 1. Similarly, if I take suppose a to the an, this will be equal to 1 2 n 0 1. Right, answer will be equal to option C. Let's move to the next question, question number 31. So if I equate by equality of matrices, if I equate, you get 3x plus 7 is equal to 0, right? And if I equate 5 is equal to y minus 2, right? And then y plus 1 is equal to 8, and 2 minus 3x is equal to 4. From this, y is equal to 7. Right, here also I get y equal to 7, so obviously value of y is unique. But here I get 3x is equal to minus 7 by 2, right? Minus 7, x is equal to minus 7 by 3. And then you get minus 2 by 3 is equal to x. I'm getting two values of x which doesn't satisfy this. Not possible to find. Question number 32. A plus A transpose is equal to I, right? According to the question, A plus A dash is equal to I. A is equal to cos alpha minus sin alpha. This is sin alpha and cos alpha. This is A plus A transpose. First row becomes first column. So this is cos alpha minus sin alpha. This will be sin alpha and cos alpha. And I will be equal to 1 0 0 1. If I equate them, you will get this is 2 cos alpha. This is 0, and then 2 cos alpha is equal to matrix 1 0 0 1. If I equate them, you will get 2 cos alpha is equal to 1. Okay, cos alpha is equal to 1 by 2. Cos alpha is equal to cos of pi by 3, because cos 60 is half. Now if I equate, alpha is equal to pi by 3. Answer is option B. Right, question number 33. A square should be equal to I, then which of the following is true? A square is equal to, this is alpha and then beta, gamma and minus alpha. Again, this is equal to alpha, beta, gamma and minus alpha. If I multiply first row, first column, you will get alpha square plus beta gamma. Right, and then first row, second column, alpha beta minus alpha beta. Second row, first column, gamma alpha minus alpha gamma. Second row, second column, gamma beta plus alpha square. Okay, so according to the question, A square is equal to I, right? A square equal to I should be equal to alpha. So this will be alpha square plus beta gamma, right? This will be 0. This is also 0. This will cancel this as well. Then this is gamma beta plus alpha square is equal to 1 0 0 1. Right, now if I equate, you will get this is alpha square plus beta gamma is equal to 1. Right, so I can write this as alpha square. I can write this as 1 minus alpha square minus beta gamma is equal to 0. Right, answer is option C only. That is 1 minus alpha square minus beta gamma is equal to 0. Answer is option C. Right, let's move to the next question. Question number 34. If A is a square matrix such that A square is equal to A, A square is equal to A means it's like identity, right? What is I plus A the whole cube minus 7A? See, there are two ways. Either you solve in the normal method and get the answer, right? Or you consider A is equal to I, because A square is A. A square is A means A should be equal to I. Matrix A should be equal to I. Only square of identity you get back the same thing. Or if I use A plus B the whole cube here, you will get A cube plus B cube plus 3AB into A plus B. Okay, minus 7A. I square is I. I cube is I. A square is A square. A cube is A square into A. A square is A, right? According to the question, right? Into A. Again, this is A square. A square is equal to A. So this A cube is equal to A only. Plus this is equal to 3A I square. Plus this is equal to 3 A square into I minus 7A is equal to I plus A, plus this is 3 I square is I into A is A only. So if you have A into I square, let me write here A into I square is A only. I square is I, sorry. A into I is equal to A. This fellow will be equal to A only. Plus this is 3 times, if you have A square into I, A square is A only, right? A into I is equal to A. Minus this is 7A. 3 plus 3, 6, 6 plus 1, 7. 7 will cancel 7. You get I. Answer is option C. You understand? Or you can solve like this, guys. As I told you. Alright, now let's say if you have A square is equal to A, right? A square is equal to A means obviously A should be equal to I, right? A should be equal to, because identity square, I square should be equal to I. That's why. Now if I write I plus A the whole cube, right? Minus 7A. Now if I write this is I plus I the whole cube. Minus this is 7 into I. I cube is I only. A is equal to I. This is 2I the whole cube plus 7I. A should be identity, right? Yes, this is equal to 8. 2 plus 2 the whole cube is 8I. 8I cube is I only minus 7I, which is equal to I only. This I is same as A. Right? So this is same as I, guys. That is same as I square is I. That is same as identity I. Answer option C only. Or you square it, but I feel this is better. I feel the second method is better. Within 30 seconds, you get the answer. A square is equal to A means A should be equal to I only. Substitute, you will get still a final answer as I only, rather than you simplify everything. Right. Question number 35. A matrix which is both symmetric and skew symmetric should be null matrix only, right? A matrix which is both symmetric and skew symmetric should be a zero matrix. Symmetric matrix means A transpose should be equal to A. Skew symmetric means A transpose should be equal to minus A. From this you get A transpose is equal to minus, you keep as it is. A is same as my A transpose. So 2A transpose is equal to 0. That is A transpose is 0. A transpose is 0 means A is equal to 0. It should be a null matrix. Zero matrix. Okay, question number 36. It's a direct question. This is x square minus 36, right? Is equal to 36 minus 18 into 2 is 36. This will cancel. X square minus 36 is 0. X square is equal to 36. X is equal to plus minus 6. Answer will be equal to option B only. It's a direct, very simple question, guys. Just expand and equate, you will get the value of x. Okay, question number 37. If a triangle has, if the area of the triangle is 35 square units, then what should be the value of k? These are the vertices. Area of the triangle is half of determinant of x1 by 1, 1, x2 y2 1 and x3 y3 1 is equal to plus minus area of the triangle is 35. This is plus minus 35. Now determinant is equal to plus minus 70. Plus minus 70. So this is x1 by 1 1. x2 y2 1, that is 5 4 1. x3 y3 1 is k4 1. Okay, now if I expand this, you get 2 into delete first row first column. This is the determinant. 2 into delete first row first column, you get 4 minus 4, which is 0. Right, plus 6. Delete first row second column. Delete first row second column, you get 5 minus k. And delete first row last column, you will get this as 20 minus 4k is equal to plus minus 70. Anyways, this is 0. You get 30 minus 6k plus 20 minus 4k is equal to plus minus 70. Right, now this is equal to determinant of 50 minus 10k is equal to plus minus 70. If you divide by 10, if I divide throughout by 10, divide throughout by 10, you get 5 minus k is equal to plus minus 7, right? Two cases will be there. 5 minus k is equal to 7 and 5 minus k is equal to minus 7. From this you get 5 minus 7 is equal to k. You get k is equal to minus 2. And 5 plus 7 equal to k. K is equal to 12. K is minus 2, k is equal to plus 12. Answer is option D. Right? Question number 38. If A is an invertible matrix of order 2, what is the determinant of A inverse? The determinant of A inverse can be written as determinant A whole inverse, right? It's the same as 1 by determinant of A. 1 by determinant of A is same as 1 by det A. Answer is option B. Question number 39. Area cannot be negative. Correct, Sagar. You're right. Where are you? Where is this question? Area cannot be negative, but value of a determinant can be negative. K can be 2. K can be minus 2. No problem. Area is always positive. K, he's asking anyways the value of K, right? K can be negative. What is there? You understand? It is possible. K is equal to 12. K is equal to minus 2. That's the answer. Here determinant area is always positive, but determinant can be negative. That's why we will take plus minus 35. Is that okay, Sagar? Can I proceed? Determinant of adjoint A. Determinant of adjoint A is determinant A per n minus 1. N stands for order of the matrix. N equal to 3, right? Determinant A power 3 minus 1. That is determinant A square. Answer is option B. Okay, question number 40. It's given the question that theta lies between 0 and 2 pi. Then what is the range of det? Okay, now determinant A is equal to delete first row first column, you get 1 plus sine square, right? Minus sine into delete first row second column, you get minus sine plus sine. Okay, plus 1 delete first row last column, you will get this as sine square plus 1. Anyways, this will cancel. You get determinant A is equal to 1 plus sine square plus 1 plus sine square is 2 into 1 plus sine square. Right, so this is determinant A. Now sine lies between sine square lies between 0 and 1, right? Sorry, sine square lies between 0 and 1, right? Now I want 1 plus sine square, right? Add 1. You will get 1 is less than or equal to 1 plus sine square, less than or equal to 2. Right? If you multiply by 2, you will get 2 is less than or equal to 2 into 1 plus sine square, less than or equal to 4. Therefore, 2 is less than or equal to det A, that is determinant of A is less than or equal to 4. So det A belongs to close interval 2 comma 4. Right? Det A belongs to close interval 2 comma 4. Answer should be option D only. Question number 41. Yeah, I am supposed to find out what is det of adjoint A. That is determinant of adjoint A is equal to determinant of adjoint A is determinant A per n minus 1. N stands for order of the matrix. N equal to 3. Now determinant A is equal to, if I multiply the principal diagonal elements, this is equal to A cube. This is A cube whole to the power of 3 minus 1. This is A cube the whole square. Okay, and powers are multiplied, you get A power 6. This A power 6, answer is option C. Right, question number 42. This is theta. This is not 0, this is theta. Okay, now A transpose plus A is equal to I. A transpose is equal to, first row becomes first column. This is cos theta minus sin theta. This is sin theta cos theta. A plus A transpose, if I add, you get 2 cos theta. This is 0, this is 0 and 2 cos theta is equal to I. I can be written as I2 means it's a unit matrix of order 2. That is 1 0 0 1. If I equate, you get 2 cos theta is equal to 1. That is cos theta is equal to half. Okay, now cos theta is equal to cos of pi by 3. Cos pi by 3. Now this is of the form cos theta is equal to cos alpha. Cos theta equal to cos alpha means theta is equal to 2n pi plus minus alpha. So you get theta is equal to 2n pi plus minus alpha is plus minus pi by 3. Answer is option C only. N is an integer, n belongs to Z. Okay, question number 43. We did a similar question in the previous video, guys. B square can be written as B into B, right? And B is same as BA, right? And B is same as BA. B is same as BA. Now matrix multiplication is associative, B into A, right? This B I'll keep as it is. BA is same as B. So this is B into A. B I'll keep as it is. Again B into A is equal to B. B into A is equal to B is same as BA, B is same as BA, AB is same as A, right? Sorry. This AB, B I'll keep as it is. This AB is same as A into A. Again BA is same as B into A. Again BA is same as B. B square is same as B. Answer is option A. Question number 43. Question number 44. Okay, I'm supposed to find out matrix X, right? Now 2x is equal to matrix 3 8 7 2 minus this will be equal to 1 2 3 4. Okay, now if I subtract, you get 2x is equal to matrix. You will get 2, 6 and 4 minus 2. If you divide by 2, x is equal to, you will get 1, 3, 2 minus 1. Okay, 1, 3, 2 minus 1. Answer is option A only. The D is missing. You can take any option here. You take 2 minus 6, 4, 2 if you want. Right. Question number 45. See, whenever you get such questions, right, no need to use expand this and simplify and take the answer. If it is true for ABC, then it should be true for obviously for any value of ABC. What I'll do is I'm going to take A is equal to 1, B is equal to 2, C is equal to 3. Or you take A0, B1, C2, anything. So this becomes determinant of 1, 1, 1. BC is 6, CA. BC is 6, CA is 3, AB is 2. Again, B plus C is 5, C plus A is 4, and A plus B is 3. Delete first row, first column, 9 minus 8. Delete first row, second column, you get 18 minus 10. Delete first row, last column, you get 24 minus 15. So we go to 1 minus 8, and then plus this will be 9. 9 minus 9 is 0. 9, no, this should be equal to 2, right? Sorry, this is equal to plus 2. Now this is ruled out. This is ruled out. Now let me check. A minus 1, A minus B, 1 minus 2 is minus 1. B minus C, this is also minus 1. C minus A is plus 2. You multiply, you get plus 2. This will not satisfy. If you want, you substitute and check. A plus B is 3. B plus C is 5. C plus A is 4. This will be equal to 60. So this doesn't satisfy. Answer is option B only. Right? Let's move to the next question. Is it clear, guys? See, I told you whenever in a determinant, whenever the numbers are in arrangement of numbers are in AP, then the value of a determinant is always 0. Suppose I take determinant, you change R2 to R2 minus R1. First row is 441, right? So 442, this is 443. Now if I subtract, you get 4. This is 4, this is 4. Change R3 to R3 minus R2. Or you can take R3 minus R1 as well. Change R3 to R3 minus R2. If you subtract, you will get this as 4. Even this is 4, this is 4. Two rows are same, identical, answer is 0. Right? Let's move to the next question. See, I'm supposed to find the inverse of this matrix. A inverse is 1 by determinant A into adjoint A, right? In the board exams also, you did the same thing, right? Now determinant is equal to, this is cos square 2 theta, minus and minus is plus sin square 2 theta. Sin square 2 theta plus cos square theta is 1. Now I should find the adjoint. Adjoint, how do you find? Interchange the diagonal elements and change the sign of other elements. So this is cos 2 theta, this is cos 2 theta. Interchange the diagonal elements, change the sign of other elements. So this is plus sin 2 theta, this is minus sin 2 theta. Okay, so cos sin minus sin 2 theta cos 2 theta. Answer is option D only. Right? Question number 48. The solution of the equation is, if I expand this determinant, delete first row, first column, this will be equal to 5x minus 2x. Minus 2 into delete first row, second column, you will get this is 2x plus x. Minus 1, delete first row, last column, you get 4 plus 5 is equal to 0. Okay, so now this is 3x, right? So this becomes 3x square. Minus 3x, right? 3x into 2 is equal to 6x. Minus 9 equal to 0. If you divide by 3, If you divide throughout by 3, you get x square minus 2x minus 3 equal to 0. Right? Split the middle term. Minus 3 plus 1 is minus 2. Multiply, you get minus 3. X minus 3 into x plus 1 is 0. You will get x is equal to 3 and x is equal to minus 1. Answer is option A. Right? Let's move to the next question. Question number 49. Don't multiply AB and then you take the determinant. Determinant of AB is always equal to determinant A into determinant B, right? Determinant of A is equal to 0 minus 10 and determinant of B is equal to minus 10 minus 0, which is minus 10. Minus 10 into minus 10, which is equal to 100. Answer is 100. Options are missing, guys. Answer is 100 only. Question number 50. Inverse of the matrix. Right? We'll use the same formula. A inverse is what? A inverse is 1 by determinant A into adjoint of A, right? A inverse is 1 by determinant A into adjoint of A. Determinant A is equal to 5 plus 6, which is equal to 11. This is 11. Adjoint will be equal to interchange the diagonal elements. This is 1, 5. Change the sign of other elements 2 and minus 3. Right, answer is option A. Question number 51. See, I'm supposed to find out what is matrix B, right? 2A plus 3B is equal to matrix 2 minus 1, 4, 3, 2, 5. And then this is A plus 2B is equal to matrix 5, 0, 3 and 1, 6, 2. You call equation 1, you call this is equation 2. In order to eliminate A, right, I'll multiply this by 2. If I multiply the second equation by 2, you will get 2A plus 3B is equal to matrix 2 minus 1, 4, 3, 2, 5. And if you multiply 2, you get 2A plus 4B is equal to matrix 10, 0, 6. And then you get 2, 12 and 4. Right, now if I subtract, this is minus, minus and minus. This fellow will cancel. Minus B is equal to matrix. If I subtract now, you will get minus 8, minus 1, minus 2. And then you get 1, minus 10 and plus 1. If you shift B minus inside, you will get this as 8, 1, 2. And then you get minus 1, 10 and minus 1. Answer will be C only. Right? Let's move to the next question. In this, I should check in which of the following is not defined. Sum is, if I take suppose C is a matrix of order 3 by 3, right? Okay, A is a matrix of order 2 by 3. First option. B dash is a matrix of order 2 by 3. So sum is obviously defined. You understand, two matrices can be added or subtracted only when the orders are same. So this means that A plus B dash is also a matrix of order 2 by 3 only. But now you can't multiply this. You can multiply only when the number of columns of first should be same as number of rows of second. You can't multiply. So this 52 doesn't exist. Is that clear, guys? So 52 doesn't exist. Question number 53. I can write this as a square minus 5a plus 10i is equal to 0, right? I'm shifting here. A square is equal to 1 minus 3 2k. Given this is 1 minus 3 2k. First row first column you will get this is 1 minus 6. First row second column minus 3 minus 3k. Second row first column is 2 plus 2k. Second row last column is minus 6 plus k square. So this will be equal to minus 5 minus 3 minus 3k, 2 plus 2k. This is minus 6 plus k square. Minus into a bracket. Okay, now if I multiply 5, you will get this is 5 minus 15. This is 10 and 5k. This fellow will be equal to 10 0 0 10. Now if I equate, minus 5 plus 10 should be 0 only, exclude. Minus 3 minus 3k, minus of minus plus 15 equal to 0. 2 plus 2k minus 10 equal to 0. Minus 6 plus k square minus 5k plus 10 is equal to 0. Let me check. So anyways this is 0, exclude. This will be equal to minus 3k plus 12 is equal to 0, k is equal to 4. Here you get 2k minus 8 equal to 0, k is equal to 4 only. Here if I take k square minus 5k plus 4 is equal to 0. Right, minus 4 minus 1. So this is k minus 1 into k minus 4 is equal to 0. K is equal to 1 and k is equal to 4. If k equal to 1 doesn't satisfy these two. Only k equal to 4. So this is 4 but not 1. Good question, guys. Right, so if, I repeat, k equal to 1 doesn't satisfy k equal to 4 and k equal to 4. So value answer is k equal to 4 but not 1. So I'll stop here, guys. Please do watch, like and share my video. If you haven't subscribed, please do subscribe my channel. I'll start with part 3 in my next